before where you had like terms, with radicals, we have to have like radicals, which means that you have to have the same index and the same radical. Same radicand and same index. So here, if I have root 3 plus 4 root 3's, that can make 5 root 3's. But I can't put the 2 root 7 together with them. This would be as simplified as it gets. So when we get to example 1 here, in part A, can you see they're both part of the root 5 family? So if you had 9 root 5's minus 5 root 5's, you'd be left with 4 root 5's. No problem. But it's not always that they're simplified like this all the way. The first thing we're going to have to do is simplify. And for a radical, this means that we need to write as a mixed radical. So in the first example, they were already mixed radicals, and we could say a mixed radical in lowest terms, root 5 is the smallest family that you could get there. But in the second one, where we have cube roots, these are written as entire radicals. So our job is step 1, we have to simplify and write it as mixed radicals. Since they're cube roots, remember that powers chart that we made? You'd go to your cubes, and you would notice that 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. That's from my column of my powers of 3. Those numbers are important because I have to check, does 24 divide by one of those? Right? I know 24 is 6 times 4, but that's not in my cubes powers chart. 24, though, is 8 times 3. So I can break up 24 to be the cube root of 8 times the cube root of 3 minus. What about 192? And sometimes you'll take out your calculator and you'll be like, okay, well, 192 doesn't divide nicely by 125. Let's see if it divides nicely by 64. So I take out my calculator. Here, I'll do it on the screen here. I take 192. I check, does it divide nicely by 64? Ah, my calculator is... Okay, that's working. 192 divided by 64. Does that work out nicely? It does. So then I could write that as the cube root of 64 times the cube root of 3. And next I have 375. 375 divides nicely by 25. I can go to my calculator. Sorry, by 125. I can go to my calculator and check, and it's 3. So it's equal to cube root of 125 times the cube root of 3. Number one mistake that happens in this is students like to be lazy. You have to write that little 3. That's annoying for you, so you decide not to write it. And then that's annoying for me, because then I have to take off a half a mark for not writing it down correctly. So I broke up 24, 8 times 3. 192, 64 times 3. 375, 125 times 3. I can simplify this. Cube root of 8, that's on my powers chart. That means I have 2 of them. Cube root of 64, that's 4 of them. And then cube root of 125, that's 5. And now we notice that they're all like radicals. They have the same index. They're all cube roots. They have the same radicand. That's the number inside. Is 3 inside each of these. So they're like terms. And it's as easy as having 2 minus 4 minus 5. Can you see that you would end up with negative 7 of them? So our final answer is negative 7 cube root of 3. And same thing in part C, we're dealing with square roots. So in my powers chart, I look back at my powers chart, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49. How high do my numbers go here? Do I have to probably keep going? No, I probably don't have to keep going. So I start off with the square root of 63. Do any of these divide 63? And this is where your times table becomes really important. If your times table you find right now is kind of like mediocre, right? If you don't recognize that 63 is 9 times 7 right away, okay? That means you have to practice your times table. It will help you a ton in this course to have your times table done really well. And it has to be done well so that when you see a number like 63, you can automatically tell that it's 9 times 7. And 40. Well, 40 is a bunch of different things. It's 8 times 5, 10 times 4, 2 times 20, 1 times 40. But it's only one thing that uses these numbers. So since I have to use one of these, I'm going to write 40 as 4 times 10. Next, I have negative 90. That's 9 times 10. That's helpful because of the 9. And finally, 28 is 4 times 7. So 63 is root 9 times 7. That's square root of 9 is 3, so this is 3 root 7s. Square root of 4 is 2. This will be 2 root 10s. Square root of 9 is 3, so this is 3 root 10s. And square root of 4 is 2 root 7s. I don't mind. Did I make a math error somewhere?
For minus 2 root 7.
Oh, the last one should be a minus sign? Thank you. There we go. Yes, they're all negatives there at the end. Okay, so now that I have them like this, can you see that the root 7s are the same family and the root 10s are the same family? So just like adding like terms, 3 root 7s minus 2 root 7s would be 1 root 7. You could write a 1 out in front, but you don't need to. 1 root 7 we can just write as a root 7. And 2 root 10s minus 3 root 10s will be minus 1 root 10. So we're left with root 7 minus root 10. Okay? I don't mind if you are able to mental math, go directly from here to here, that's perfectly fine. If you can see that 63 is 9 times 7 and the square root of 9 is 3, and change root 63 to 3 root 7, perfectly fine. It's not bad if you show the extra step, right, and have root 9 and root 7, okay? But we have to be careful here, because I see students, I don't know why, this happens a lot. So watch this. Square root of 63, they're like, square root of 9 times square root of 7. Okay? I see this going square root of 3. See, square root of 9 is 3, right? But you're writing square roots, can you see yourself just not thinking for a second and adding an extra square root? And then you're like, oh, that's weird. Maybe I'll just change that to root 21. Well, no, can't do that. I also see this. You're like, ooh, it's the 9, so they just write 9 root 7. Well, that also is a mistake, because it's supposed to be the square root of 9. So we have these possible errors, and you have to be careful as you're going through. Okay? Questions for practice for this one? Take a couple minutes and try 3, 4, and 9.